Hey y'all, we are starting triangle proofs today. I'm so excited about this. So last time we talked about side, 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 angle, side, angle. All of those are in here now, and still, I guess. So they're all in here. You can see any one of them. We're basically going to use these four. We're not going to use HL yet, and then these ones just kind of exist from earlier. So what I'm going to do is I'm going to do two, maybe three, if I can fit it, examples on here, and then you're going to try examples on your own. And the next time I'm going to come back and do more examples, and then you're going to try more examples. We're just going to keep going like that because triangle proofs are so unique that sometimes you just have to do a bunch to get the hang of it. So I'm going to start adding more and more things as I go. But for right now, all we're going to worry about is if there's vertical angles or a reflexive side, and then which one do we use. So let's get started. All right, pause to let you, I'm going to let you write all this down. So, okay, good job. I don't know if you're done yet or not. I'm going to mark up my triangles before I write anything down in the proof because I want to understand what my mind is thinking. Okay, so I have this first statement right here. PQ, which is that line down the middle, bisects angle SPT. What does that mean? Bisects means cuts in half. So that means that this angle right here, SPQ, would be equal to this angle right here, QPT. Okay, the other thing that I know is that SP is the same as TP. Congruent to, that's what that little symbol means, by the way. So S to P is the same as P to T. Okay, so I already have an angle and a side. Do I have anything else? Heck yeah, I do. I have more colors is what I have. Red, why not? Okay, so the last thing I know is that PQ is equal to PQ because it's the same as itself. That's where that reflexive property comes in handy. And then here's what I'm going to have at the end. I have a side, an angle, and a side. So I have SAS, which is a legal one that I can do. SAS needs a side, an angle in between it, and then another side. So this is perfect for that. So let's write out the proof. I'm not going to write the line down the middle just yet because I want to kind of see how big this is. I think it's going to be, let's see, 1, 2, 3, 4, 5 steps. But let's see if we can do it in that many. So I already know that PQ bisects angle SPT was given. And then from that, remember how I drew it on the triangle? From that, I know that angle SPQ is congruent to angle TPQ. That was the definition of bisects. Okay. Now, I know you wanted to write the next part first. It does not matter. I don't care if this came before that or the other way around, because that's another given statement. But I wanted to follow that train of thought before I lost it. I want to get on the train before it leaves the station. Okay, so I have the SP and the TP are the same, and that was a dead end thought because that's all I needed. And then I know that PQ is congruent to PQ, which I know sounds silly, and that's why we haven't really used it yet, but that's just a statement of fact. Now, that's the reflexive. It's not the reflexive property of equality anymore because this is a congruent statement. But what we can do is we can just call it the reflexive property. I don't know if your book lets you, but we're going to do it. It's okay. All right, and then I need to end with a statement I wanted to prove because right now I have, actually let me label this here. So I have a side, I have this side, and I have the angle between it. It's gonna look bad. I'm just gonna put it right here, but I'm gonna draw a line to that one because I don't want to spell bad words on my paper. I shouldn't have done it that way, but it's fine. Okay, so that tells me that triangle SPQ is indeed congruent to triangle TPQ by side, angle, side. Was that 5? That was 5. I did it. Great. And that's all she wrote. Oh, I do a little box because I'm done. QED, quadrant demonstrandum. Does anybody remember that? Maybe I'll give that to you on like a quiz somewhere. What does QED stand for? Y'all just look it up, I know. All right, let's do another one. Let me pause this so I can write it. Pause so you can write it now. All right, so we're given some certain things here. We're given that AD right here is parallel to EC. And we're given that B to D is congruent to B to C. Finally, we know in our hearts that vertical angles are congruent. So that part's the vertical angle theorem. We're going to talk about that again in just a second. Vertical angles are congruent though. Okay, so right now we have an angle and a side. We can't use this side over here. We don't know that they're congruent, first of all. And second of all, that would be the angle side theorem, which is swearing, and we can't do that one. It's not because it's swearing. Watch my other video. But it's not possible. Okay, but I could use angle side angle if I knew that angle D and angle C were congruent. Are they congruent? Let's find out. Okay, so how I want you to picture this is, okay, let's think that these are the same. These are parallel lines. We've done this before where we have parallel lines in a transversal, right? It doesn't quite look like that, but that's what we did. I don't remember. Hold on, let me show you. It got folded. It's this day, 1E and 1F, right? So parallel lines and transversals, and it doesn't look like it because there's a triangle in it. Sorry, but they are the same because I have two alternate interior angles with two lines and a transversal. So that'll actually get me that, and then I'm done. So let's write it out. So here's my statement. Do I have justification there? I just don't want the D to be part of this. Okay, so AD is parallel to EC. That was given. Okay, that also told us that those angles were congruent. So that told us that angle D was congruent to angle C, and that was because of the alternate interior angle theorem. That was a weird L. Interior angle theorem. And I'm not making this up. That's actually how you're going to do this. But if you want a reminder, if you go to angles, here's the alternate interior angle theorem. It says that alternate interior angles are congruent if the two lines are parallel. If we wanted to go the other way, we use the converse, but we don't need to go the other way. Okay, so then BD was congruent to BC. I was really sloppy on this one. These are all lines. Line segments. Okay, that was given. And then these two angles were the same. So let's label them. ABD is congruent to. Now it's in my heart to say CBE, but I actually kind of want to go the other way because this triangle is twisted. So it's actually congruent to angle EBC. End of the world? Absolutely not. And that's the vertical angle theorem, which is VAT. I don't care if you just write VAT. I'm going to start doing that, but I wanted to write it out in case you were confused. Because it happens. It's fine, though. I forgot to turn off your midterm. Oops, I'm going to go do that. Okay, and then let's see. Let me just mark it up here. I have angle, side, angle. So then I know that triangle ABD is congruent to triangle EBC because of angle, side, angle. I'm done. Let me go find another one because I do have enough room for it. All right, here's the last one. We're given that L, M, and JK are congruent, and that M, J, and KL are congruent. And then some of the J's I did, and some did, I don't know. And then I want to prove that these two triangles are the same. There are two triangles here, even though it looks like a rectangle. That's the top one and the bottom one. All right, let's walk through it again. So L, M, and JK are congruent. So it tells me these two. And then MJ and KL are congruent. Okay, well then I only need, can I find any angles that are the same? No, but I know that this one is the same as itself because it's reflexive again. So I have a 3-step proof basically. Well, 4 with the extra thing, but let's get it done. Well, I want 4. There we go. Okay, so statement and justification. All right. So I know the two given statements. Oops. That's fine. LM is congruent to JK. MJ is congruent to KL. Those are both given. And then this JL is congruent to JL. And I know that sounds redundant. I promise it's going to sound redundant, but it just is. We have to state it though, because otherwise we're just saying that two sides make a full triangle. Okay, and then that's it. That's all she wrote. LMJ is congruent, whoa, to JKL. Do you see this congruent symbol? Ugh. And that's because of the side, side, side. I have side, side, side. Done. QED. There's my little tombstone. That's all she wrote. I don't know why I keep saying that. I'll see you in class 4. We're going to practice just looking at the triangles and knowing what it is some more. And then next time after that, we're going to go through and do some more examples of this. I don't know, slides or Desmos. Not really sure yet. All right. Hope that helps. Okay, bye.